In this video, we will be solving trig equations such as this one by factoring. Now, along the way, I'm going to assume that you have memorized this set of facts. So if you have not memorized these yet, pause the screen right now and memorize them before you go on. So problem number one. One of the main tools in our toolkit is factoring out the greatest common factor. So as soon as I see that we have a cosine here and a cosine here, that's setting off my GCF warning bell. So I'm going to take that common factor outside of parentheses. That will leave behind 2 sine x minus 1. Now I've separated the cosine and sine, so I can go ahead and use my zero product property and set each one of these factors equal to 0 and solve separately. So where is cosine equal to 0? Well, we are talking about quadrantal angles right now. So this is 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Cosine is an x value. So the question is, where is the x value 0? The x value is 0 here and here. So these two angles will be solutions. So that will give me the solution x is equal to pi over 2 and 3 pi over 2. Okay, now what about the other side? Adding 1 to both sides, I have 2 sine x is equal to 1. Dividing both sides by 2, I have sine x is equal to 1/2. Now, where is sine x equal to 1/2? Hopefully you're thinking pi over 6. Sine of pi over 6 is 1/2. Now, pi over 6 is just the reference angle. So in my mind, I'm thinking the reference angle is pi over 6. That's not the solution. It just tells me what type of diagram I should be drawing or picturing in my brain. So I'm drawing a diagram of pi over 6's, which the pieces are so small that it is tricky to draw. So you're going to have to forgive me for how janky looking it is. These are the 4 angles that have a reference angle of pi over 6. The sine of any of them will give me some kind of 1/2, but these two will be positive 1/2 and these two will be negative 1/2. Sine is the y value. It's positive up and negative down. In this particular case, we want positive 1/2. So that's why these two angles will be our solutions. So added on to the list will be pi over 6 and 5 pi over 6. So these are the 4 solutions to the equation number 1. Let's take a look at problem number 2. Let's go ahead and get 0 on one side by subtracting tangent x. That is going to give us tangent x sine squared x minus tangent x is equal to 0. Again, I see a common factor. As soon as I see the tangent x here and here, I know that's a common factor. If I take that tangent x and pull it outside of parentheses, that's going to leave behind sine squared x minus 1. Now we can use our zero product property and set each one of these equal to 0. So tangent x is equal to 0 and sine squared x minus 1 is equal to 0. We need to solve both of these. Adding 1 to both sides, I have sine squared x is equal to 1. Taking the square root of both sides, I'm going to have sine x is equal to plus or minus 1. Okay, don't forget, whenever you take the square root of both sides, the solution can be positive or negative, so you really need the plus or minus here. Now, where is tangent equal to 0? For that, it helps to analyze our quadrantal angles. So I'll just draw a quick diagram over here, where this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. Remembering that tangent is y over x. Tangent right here would be 0, all right, because 0 over 1 is 0. Tangent here would be undefined because 1 over 0, you can't divide by 0. Tangent here, this is 0 over negative 1, so this would be 0. And tangent here again would be undefined, y over x. Negative 1 divided by 0, you can't divide by 0. So these are the values of tangent. So where is tangent 0? Tangent is 0 here and here, as you can see. So that's going to give me my first two solutions. So I will have x is equal to 0 and pi. So I have 0 and I have pi so far. Now, where is sine equal to 1 or negative 1? Let me just change colors a little bit, because we're also talking about quadrantal angles again. Sine is a y value, so we're asking where is the y value equal to 1 or negative 1? Okay, well that's 0, there's 1, that's 0, there's negative 1. Okay, so the y value is equal to 1 or negative 1 here and here. So I'm going to have two additional solutions that I'm going to add on to my list of pi over 2 and 3 pi over 2. So these are the four solutions to number 2. Looking at number 3, it seems like all we have to do is take the square root of both sides. So if I take the square root of both sides here, I'm going to get tangent x is equal to plus or minus the square root of 3. Don't forget, when you take the square root of both sides, the solution is positive or negative. So the question is, where is the tangent, the square root of 3? Let's think about the reference angle. Well, we know that the tangent of pi over 3 is radical 3. So that means that the reference angle is going to be pi over 3. So consider this diagram of pi over 3's just to help you focus your mind better. These are the four angles that have a reference angle of pi over 3. All of them will give me some kind of radical 3 when I take the tangent. It's just that this will be positive radical 3 here and here, and it will be negative radical 3 here and here. But we want positive or negative radical 3. So we want all four, so we will have the following four solutions. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, that's it for number 3. Pretty simple. For number 4, there is no GCF, but this looks like something that we can factor. So let's go ahead and try to factor this. 2 sine squared x can only factor as 2 sine x times sine x. 1 can only factor as 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 sine x. outer, I have 2 sine x. The middle is 3 sine x. That will happen if I just leave these both to be positive. So that means both of these will be positive. Will that give me a positive 1 at the end? Yes, positive 1 times positive 1 is positive 1. So this is how you factor it. Now we can go ahead and do the zero product property and set each factor equal to 0. So I have 2 sine x plus 1 equals 0, and I have sine x plus 1 equals 0. Subtracting 1 from both sides, I have 2 sine x is equal to negative 1. Dividing both sides by 2, I have sine x is equal to negative 1/2. Subtracting 1 from both sides, I have sine x is equal to negative 1. So where is sine equal to negative 1/2? Well, ignore the negative sign for a second. The sine of what angle is 1/2? We know that to be pi over 6. Sine of pi over 6 is 1/2. That tells me that the reference angle is pi over 6. Okay, so here comes the diagram of pi over 6's. Now, when you get comfortable with this, you won't draw the diagram. You will picture it in your mind, but I'm going to draw it for instructional purposes. All right, this is what you should be visualizing in your brain. Only, hopefully in your mind it's neater. These are the 4 angles that have a reference angle of pi over 6. The sine of any of these angles will be some kind of 1/2. It's just that these two will be positive 1/2 and these two will be negative 1/2. Sine is a y value on the unit circle, positive up and negative down. In this particular case, I want negative 1/2. So that's why these 2 angles are the solutions. Okay, so far that gives me x is equal to 7 pi over 6 and 11 pi over 6. Okay, now how about the other side? Sine x is equal to negative 1. Well, for that, we are talking about quadrantal angles. So I'm going to draw another diagram showing my quadrantal angles. This is 1, 0. This is 0, 1. This is negative 1, 0. And this is 0, negative 1. Sine is a y value. So where is the y value equal to negative 1? Let's see, 0, 1, 0, negative 1, ding, ding, ding. This is the angle where the sine is negative 1. So that's the only one, so I'm going to add that to my solution list. Okay, so I will also have 3 pi over 2 as a solution. All right, those are the 3 solutions for number 4. All right, number 5 has a little bit of a twist to it. I'm noticing that we have sine and cosine. I'm thinking ahead, even if I subtract this from both sides, there will be no GCF that I can pull out to separate these two. So I'm going to need to do some type of substitution to turn this into all one type of equation. So what I'm going to need are my Pythagorean identities. So this is another set of information that you need to have memorized. At the very least, you need to have memorized the yellow versions of the Pythagorean identity. There are really just 3 of them because these are duplicated. And the blue and pink versions are just manipulations of those that you can get to very quickly. But you should be able to generate this chart in about a minute on scratch paper or something. So anyway, looking at this problem, and looking at my identities, notice that all of these identities involve something squared. So these two up here involve sine squared and cosine squared. And so I'm looking at this cosine squared, and I'm thinking, where's that? Well, see this blue right here? Cosine squared is equal to 1 minus sine squared. So let's do that substitution. So I'm going to take this cosine squared, and I'm going to replace it with 1 minus sine squared. So that means I'm going to have over here 2 times, and in parentheses I'll put 1 minus sine squared. All right, and over here, of course, I have 3 sine x. So now I have all sine instead of a mixture of sine and cosine. So I will just do the distributive property here. So that's going to give me 3 sine x is equal to 2 minus 2 sine squared x. All right, let's get 0 on one side and see if we can factor. So I'm going to add 2 sine squared x to both sides. And I'm going to subtract 2 from both sides. All right, that's going to give me 0 over here. And I will carefully put these 3 terms in the correct order, descending exponential order. So my sine squared x, my 2 sine squared x goes first. Next comes my 3 sine x. And last comes the minus 2. And all of that equals 0. Now this looks like something that I'm going to be able to factor. So let's give it a shot. Okay, 2 sine squared x can only factor as 2 sine x times sine x. 2 can factor as either, well, it's going to be 1 times 2, but I'm either going to put 2 here and 1 here, or I'm going to put 1 first and 2 second. Now I actually know that this way is not going to work without even trying it. That's because if the original problem doesn't have a common factor, a GCF, there should be no common factor inside of the parentheses either. If I put the 2 here, that creates a common factor inside of the parentheses. I know this is not going to turn out to be the answer. So I will save time by not even trying it that way. Instead, I will put 1 times 2 in this order. Now, inner plus outer must equal middle. Inner, I have 1 sine x. Outer, I have 4 sine x. I'm trying to get a middle of positive 3 sine x. That will happen if I have a negative 1 sine x and a positive 4 sine x. So that means this needs to be negative and this needs to be positive. Does that give me negative 2 at the end? Yes, negative 1 times positive 2 is negative 2. So here we have factored correctly. So now we can do the zero product property and set each of these equal to 0. So setting 2 sine x minus 1 equal to 0. And we're going to set sine x plus 2 equal to 0. Subtracting 1 from both sides, I'm going to get 2 sine x is equal to 1. Dividing both sides by 2, I'm going to get sine x is equal to 1/2. And over here, subtracting 2 from both sides, I'm going to get sine x is equal to negative 2. All right, now we can find the solutions. The sine of what angle is equal to 1/2? Well, I'm hoping the first thing that just popped into your mind was pi over 6. Okay, because we know the sine of pi over 6 is 1/2. Now that's just the reference angle, that's not the solution, but that will encourage me to draw the diagram of pi over 6 is. Okay, so here are my pi over 6's. These are the 4 angles that have a reference angle of pi over 6. The sign of any of these will be some kind of 1/2. It's just that these two will be positive 1/2, and these two will be negative 1/2. Sign is a y value, positive up and negative down. In this case, we want positive 1/2, so my solutions will be here and here. Okay, so that means that so far I have x equals pi over 6 and 5 pi over 6. That's weird. It's jumping around. So I have these two solutions so far. So now I turn my attention to the other part of the equation. Sine x is equal to negative 2. Well, I'm hoping that you can very quickly see that we will have no solutions here. And that's because if you think about how the sine function works, all right, we used to graph these, and when we would graph the sine function, it would go like this. Okay, the sine function would start at 0, and it would go up to 1, and it would go back to 0, and it would go down to negative 1, and it would go back. So the sine function goes up and down and back, and then it just repeats over and over and over again, up and down and up and down. But it never goes higher than 1, and it never goes lower than negative 1. So there's no angle that's going to give me negative 2 for a result. So that's why we will have no solutions here. So for that reason, these two solutions are my only solutions. All right, guys, that's going to do it for this video. I hope it was helpful, and I will see you on the next video. On the next video, we're going to do problems that will involve our double angle identities. See the 2x? So if you want to see how to solve equations using these identities, I will see you on the next video.